Hey everybody. So I wanted to go through a sorry about that. I wanted to go through a typical problem here in this section. All right, getting stuff to open still on my computer here. Here we go. So new cream. This is directly from our web work assignment. A new cream that advertises that it can reduce wrinkles and improve a subject in a recent study. A sample of 49 women over the age of 50 use a new cream for 6 months. Of those 49 women, 43 of them reported skin improvements as judged by a dermatologist. Is this evidence that the cream will improve the skin of more than 60% of women over the age of 50? Test using alpha equals 0.01. Okay, so we have two things to compute here. We have to compute a test statistic, a critical value, and then we have to make our conclusion if we reject or we fail to reject. By the way, if you look at this proportion, 43 out of 49 seems really, really high. Let's go ahead and get an Excel sheet here, and I will get this over here so we can see them both side by side. Great. Okay, so we need a couple of things here. We are going to need a few things that matter. So first thing is our sample size. Sample size. Our sample size is, of course, 49. That is, by the way, our N. Next thing we need is our proportion. Now, when I'm computing here our proportion, I mean our population parameter. So this one is the regular p, not the p hat. So this is supposed to be 60%, so 0.60. I'm also going to do our statistic. So our statistic is the one that is computed. We see our statistic is 43 divided by 49. And by the way, that's going to give me a little bit of an error here. I need to stick in equals there so that it actually goes ahead and computes that. So this is our p hat. I'm sorry, I don't actually know how to input that in the Excel with a hat over it, but that'll work for our purposes. Last thing that we have is our alpha. So our alpha value here was 0.01. Okay, so let's go ahead and establish our null and alternative hypothesis. So my null hypothesis here is going to be that p equals 0.6. My alternative hypothesis, I'm going to have to be careful here. It looks like I should be using that p is greater than 60%. We wanted to show that it improves the skin of more than 60% of women over the age of 50. So that's what I'm using here. The inequality there is important. Sorry, the greater than is important because this will be a one-tailed test. Okay, so let's see if we can get our z star before we get moving here. For my z star, because I want the alpha to be 0.1, I want to have 99% less. Now, if it's a two-tailed test, I'm going to divide that 1% in half and put half to either side. But because here I want a one-tailed test, I'm going to just use the percentage there. So what I want here is I want 1 minus my alpha. Again, if you happen to have a two-tailed test, you would have to divide this by 2. But this one happens to be a one-tailed test. Okay, so let's see if we got that right. Notice me copying and pasting. So I'm going to go ahead and check. And I did get that correct. Awesome. I think everybody will get this part correct because you can just keep guessing, right? Okay, so then let's actually compute our z. So our z here, actually let's skip a step ahead. I need the standard error, right? So the standard error we were computing with the bootstrap before. But in this section, our standard error is going to be the square root. It's always going to revolve around the p. So it's the square root of the p times 1 minus the p. And I always have trouble here. I think it's divided by n. So there is my standard error. Again, remember I'm using the parameter, not the statistic. Okay, so then the z is the statistic minus the parameter divided by the standard error. And so I get a big old z value here. Let's go ahead and copy that, paste it. And I'm going to hit check because I like to check and see that I did it right. Notice all the digits that I'm putting in here. So now we have a test statistic and a critical value. So I always like to think of my picture. If I have my picture of the of my hump of my normal curve, I say, well, I want to be above the critical value. And I clearly am here. I'm very extreme. This was an extreme result to have 43 out of the 49 women, 87% show improvement when really you only needed 60% to show improvement. So I'm going to be able to reject my null hypothesis. And when I do that, you can see I got all my answers correct. Okay, so again, the z star here, the critical value is computed by writing the null and alternative hypothesis by examining whether it's one or two tailed. The test statistic is computed by taking the statistic minus the parameter divided by the standard error. Standard error has a formula that we know and love. Sorry, let me write the formulas here, huh? So this was p hat minus p divided by the SE. And the SE was the square root of the p times 1 minus p divided by the n. So those were the two formulas that I was using there. I know I just kind of skipped over them as I went because I know them off the top of my head, but you guys probably have to look these up. So I did put them in there. And you guys can see me use that just in Excel, right? I'm using the square root. I'm calling a reference to B2. I'm doing 1 minus B2, and I'm dividing by the sample size. All right, so that's what it takes to do these questions. There's going to be lots of questions like this. Good luck. Keep working hard. You guys can do it.